Hello and happy 2022. Yes, it's New Year and I've come back from America and back in the workshop, but with a bit of news. I am an engaged person, as Arkwright would say. Yes, I'm engaged now. So sometime in the not too distant future, this will become Steve's long stay US workshop. Just let you know. And I'm looking forward to it, I really am. And so, by the way, it's Katie. Hello Katie Blaswick. I hope you're listening and I hope you enjoy this video. And I've taken the advice on the videos aboard as well, because of course I saw them on a big screen for once. I didn't know you could do that, but you can. So, having seen one on a big screen and cringed, yeah. So I'm back here in the workshop. Look at, first of all, this project of 2022. I've got a couple left over actually from last year, but so we'll come back to those. We're working on a set based on the American AA5 design, because they did come across here. This is one example. This is a pilot little Maestro. These, remember the 30s, late 30s, early 40s. But after as well with this one, I think, judging by the valves that are in it. But these sets, this one actually is designed for 240 volts, so I could just plug it straight in. But I'm not going to. I'm not going to for a very, very simple reason. No insulation whatsoever on the cable. None. So I'm not plugging this in until at least I've done that. The set, by the way, I'll just review on the set and we'll look at it in some detail before we start working on it, because always look before you leap. A bit closer up to it now, and so I can look at it in more detail. It's a standard design. Unlike the American sets, this has had long wave added, because in Britain, of course, long wave was a broadcast band. In America, it wasn't in many of the sets. Well, they came over here and they did put the long wave band on. Long wave band in America, by the way, was used for beacons and such like for shipping. So, although if you have got a long wave set out there, then maybe you might get something on it after dark, but certainly not during the daytime, unless maybe you're coastal. This set, by the way, like I said, I can't plug it in. No way, Jose. So what do you do with this set before you plug it in? Well, turning it round, taking the back off, like that, and get rid of that from the back. There we are, and this from the back as well. At some point, like that, we have a set here which follows standard American design. Rectifier, which is these are all Bremer Jesslotto valves, by the way. Pentode, diodes, and first IF amp, and of course here in this corner there's the rectifier valve. Sorry, there's the frequency changer valve, that's there. So it's called that. They all work in the basic form of a way. Of course, it will be a super hay, as you know. And of course, another thing I've noticed with this is that it's mucky inside, which is a good thing, because if it's mucky, it means it hasn't been played with yet. So first thing we do is take this beautiful radio apart and see what it has to offer us. By the way, many of these sets are actually AC/DC. This means they don't have a transformer. They are AC/DC with a large resistor, which does sometimes fail. If it does, then I usually fit a capacitive dropper. Well, let's go inside and let's have a look and see what this radio has to offer us. Right, with the unit out of the cabinet, we look closely at it again before we do anything else. The cable, by the way, it's only one pull on a switch, which fortunately on this set was wired to live. Obviously this cable has got to come out, but like or not, this is coming out, so might as well do that sort of like now. Always, by the way, I tend to leave a trail just so that I know where it's going. One of my little tricks that you see, so that goes onto there, that goes onto there like that, and this should now come out, given a little bit more help. So that going to 530. There we are. Right. Anyway, yes, it's AC/DC. This here, that is not a transformer. That is a choke for the AC smoothing. I don't know what this is, but it's come off. So look at that. That resistor then again, I don't know. That probably goes between 1/2 and the other of the smoothing capacitors, which are mounted on top of the cabinet here. Rather badly, I might say, but they'll come out. And under here, well, it's got a number of these wax capacitors. They do have to go, but if we go anywhere else, we check and we see what is okay and what it isn't. So next thing we do with this set apart, having a good look round and see where these valves go. Now that is a right, so always remember where the valves go. There's nothing wrong with using a manual for this, nothing at all, but take them out and test them for the heaters. Heaters don't work when the valve is toast, so do that now. Then if you need to get a new one, you can off eBay or something while it's well, looking on the rest of the radio. IF cans usually are okay, although usually they can put something else in. RF cans are a little bit more of a problem. So what we do then, on these, by the way, if you hold the pin, the bottom pin right towards bottom like that and count round, 1, 2, 3, count round to bottom there, the pin is there, so it's 1, 2, 3 all the way around, yeah, and 2 and 7 are the heaters. So each one comes out like that. The switch you're able to or another meter of some kind to the continuity test, and they're going across these two pins here like that and like that, and the bleep means that was okay. So that one, which is a 6X5 GT, that's a rectifier, by the way, that's okay. Okay, so the next one along is the one that costs all the money. It was out in this set actually, so I'm a bit bothered about that. It's 6V6 GT. The 6V6, by the way, was the valve that people used before things like the ELs came out, and that's okay heater-wise as well. But always check with that, by the way, because there's a capacitor here, and if it fails, it goes leaky, and it will be going leaky. It puts a lot of strain on that valve on the rest of the radio, so something else you need to know. Okay, next one is a This one's normal size actually, this one. By the way, with these, by the way, if you're not sure how to lift them out, put the set up like that and lift from the bottom. Here. A lift from the bottom. And doesn't matter how long it takes, out it comes. Okay? Like that. This is a 6K7G. Okay. But these, by the way, are the American numbering system. British valves made with the American numbering system, of course. There were many of them, and of course they were made by a firm called Brimmer. Brimmer, by the way, stands for British Made American Valve. So now, this one again, same applies. That's okay. Okay. One behind it is a again, same applies. Lift out, there we are. And this is a 6Q7G. And again, always with these valves, it always pins 2 and 5 on these. That one's okay. Right, well, there are 5 valves here, all with good heaters, so that's okay. Now, looking at this again, I'm not 100% sure, I've not got the manual yet, which is which as regards AC or DC valves. So I have to check. Well, first of all, these all seem to be 6 series valves, I think. Yeah, 6. On the Mullard, the E side, but on these, the American numberings, it's the first digit represents the heater voltage, so it's 6, 12, 50, whatever. But these are all 6, which makes me think this is probably going to be a set for AC only, which is a bit better. Now, how can you check? Well, first of all, with sets in series, it's like old-style Christmas tree lights. You pull one valve out, they all go out. Yeah. So, for example, the heaters are wired in series. In parallel, if you pull one valve out, the others will stay on. Okay. The others will stay on. I'll show you that interject in a minute. Okay. Now, this therefore might be a transformer. I can't tell for sure, but I think this might be a transformer. In which case, that is the case. Okay. If the sockets are in parallel, then one of them heater pins will probably go to ground, and the other one obviously won't. If they're in series, go from one heater pin to another, to another, to another, all the way through. That's basically how you can tell. Now, also with this one, no way you can check is look across the on-off switch on earth. Okay. Or neutral at any rate. Now on this one, they actually made it so that put my glasses on, that's all. They made it so that it's only one going to deck and another one going to the unit. Now I'm not quite sure here. I'm not quite sure because this appears to be a one pole switch, and it goes to link the live to neutral, which is not a particularly good idea. So I will obviously be looking at changing that if that is the case. So in the meantime, how can you check? Well, first of all, valves are in series they have to have the same current. Voltage doesn't matter, but they have to have the same current. That's how it works. Whether it's 1.1 amp, 0.5 amps, 100 milliamps, whatever, they all got to have the same current. Yeah. For a series string set. With the heaters in parallel, the voltages have got to be the same. So this therefore is where we go and get our heater voltages and currents and check them. The Valve Museum or Tube Museum online tells us the 6V6GT is 6.3 volts and 0.5 volt heaters, 5 amp heaters. This one is 6X5, which is a full wave rectifier. That's another clue, by the way. It's 0.8 volts on the heaters, and so therefore that obviously is a transformer and not a shunt, which is fair enough. Sometimes you can't tell, and what I'm doing here is I'm showing you how to do it. Anything UY, PY, like that, is half wave. Anything X or Z on the bollard stuff is full wave. So that is a full wave rectifier there, 6X5, which is using quite a number of sets actually after the war. So they do come across those, and they do have the problems, but generally speaking, I find that they're okay. So therefore, I'm fairly sure that is a transformer for the lot. Now, another thing you can do is check the continuity, therefore, across an off switch. I'll find it where it's meant to be. It's here, and it goes from there to there, about 205 volts. If it was all right, 106 volts, then ohms, then okay. I'll check that on the that is about okay for a main transformer of that type. It may be higher on some sets, lower on others, but generally speaking, it will tend to be higher with the set switched off and the valves are all okay and in series on the AC/DC set. That's without a transformer. But because it's got this, therefore, we can put these in separately and check each stage as we go, which is a nice little touch to have. Now, didn't wait to check, but you know, if you're not sure, what you do, put one in, not the rectifier, please not the rectifier, any other one, and see if it lights up. If it does on its own, then obviously it's a parallel string heating set. Some Japanese sets, by the way, do actually have a system where the heaters are in series or parallel, and the transformer does the heaters or the HT, but not both. It's quite a weird arrangement, but quite handy to do if you're stuck. I did it with a few of those unitary sets and one or two others back in the day. It's one of those things which you know, different people have different ideas. So what we do now, therefore, we know that goes to there. We know that what that is, we don't know. Not sure I find it soon enough. And the next thing we're going to look at, therefore, before we think about powering this up, is the capacitor that goes to the grid of the 6V6GT. That's this one. Yeah, this is a smaller version of it. And the reason we do that is because that capacitor always leaks, and when it leaks, it puts DC on the grid of this valve, where it will only be the AC. Yeah, and when that happens, you can take out the valve, you can take out the output transformer, you can take out the speaker, you can make a real mess. So go any further, you do is look and find that capacitor and change it. Now that capacitor goes from the anode of the valve previously, which is I think 6V6GT on this. I think, I'm not sure. One of these two, one of these anyway. And that's the one which you need to check. So I think it's probably going to be this one here, which goes from there to here. So I would think it's probably this capacitor here. Now, these waxy capacitors are basically no good anymore. They were okay when they were put into a set back in 1940s, but now they're 60 years old, and over time these paper caps absorb moisture. When they do some very interesting things. Very interesting and sometimes quite naughty. I'd once actually where it's halfway from changing around capacitance inside, and it was actually generating a bit of current. So they can do some pretty amazing things. Just something else that we should think about. Now, with regards to the main side of it, I'm sorry, but that has to go the other way around. It has to. It has to, because I like the chassis tied to neutral. It's just the way I am that way. I like the chassis to be tied to neutral. If it's not tied to neutral, then you'll get a shock off it. So always check that it's tied to neutral. Or close to. Now this has also another problem here, in that there is drop across this switch here. Now the way we deal with that, the two ways. One is to try a new switch, which we can do. But first of all, we do the old switch cleaner trick and see if it clears it. So get your switch cleaner like that. More than goes like that. Some will get in, don't worry. Some will get in. So do that. Operate it a few times, and it will actually, in most cases, come up. Another way to do it, by the way, just put mains across it and let the power force its way through. That's another technique that many engineers have. Or another thing you can do, and I have done this, sets of this age are very nice to work on, very nice to use, great fun, but don't leave them switched on when they're not in the room. Put one of those street things behind it and use that. So with that in mind, sometimes I just leave the switch in place for volume, and pull the switch out of circuit and just use the switch on behind it, or the plug. Capacitors, before we go any further, they have various ways of telling what value they are. This one is a 103K capacitor. Now 103K, right, now capacitors of this kind will have a number on them like that, and 103K means 10. The 3 is 3 zeros, which is 10,000 picofarads, which is 0.01 microfarads. Yeah, that's how it works. So that's basically how we do it. Yeah. For example, 224 is 22 plus 4 zeros, 220, 22, 20,000 picofarads, which is 220 nanofarads, which is 0.22 microfarads, and so it works. That's how it works. There are some which are very common in the vintage radio world, and those are the ones which you do need to put to memory. Now, as I've said, as far as capacitors go in radios, you put two engineers in the same room, and they will always put a different signal up without fail. And but one thing that they should all agree on is that the grid capacitor on the April pentode has to be changed. There's no ifs and buts. It has to be changed, or at least checked when the radio is working. But something this old, I change it on site, because a capacitor is a lot cheaper than a valve in a mains transformer or an output transformer. So it is, shall we say, prudent. So I'll put this one in and come back to you. That capacitor is now in the circuit, and I've done it by soldering onto wires the old capacitor, which is here and now there. Some people collect old capacitors. I don't know why, but there you go. I took them in the bin. Let the bin men deal with them. But anyway, the reason why I go to the wires, I don't want to damage the sockets in any way, so I go to wires purely for the sockets' sake, as it were. That again is important. So with that in, we now have a set that is safe to put this into when the time arises. Now, next thing we're going to look at with this set, with it turned over like that, can you see that on camera? Yeah, you can. Okay, is these two capacitors here. Now, these two capacitors here are the smoothing capacitors. Now, they may be okay, they might not. I don't know. But seeing as this is for somebody else, I'm going to change them. So, I have actually got on my phone a circuit of a radio of this type. So, if you've got that information, use it, of course. That's obvious. So, here we are. And so the smoothing caps on this are 16 and 16. 16 microfarads and 16 microfarads. Now, the 6X5GT will penetrate something higher if need be. So again, we'll see what I've got. But in the meantime, 6X5GT. Again, the internet's a wonderful thing. 6X5GT. GT. Like that. And the Valve Museum tells us this is limited to 16 microfarads. So that's his maximum value for that. Okay, so we want two 16 microfarad capacitors. Okay, I think we can do that. So these come out of circuit, and something goes in its place somewhere. Don't be afraid, by the way, of taking the radio like this apart component wise. If you've got the manual, you can work out where things go, and if you can't, well, there's usually somebody that can help. So don't panic about that so much, because things can be put right. So that comes off there like that. I think that's the one in question. I hope it is. Yeah, appears to it. So it's that one and that one come off, and 216s will go there. The caps are now out. One is an 8 microfarad capacitor, a TCC cap, and the other one is a Jubilier, which is 1616, but only appears to be one cap. Now, again, I shan't bother changing those, checking those, because they're probably well and truly dead or dying. So that's where they go. Now, given that, I'm not quite sure what this one will have in it, but for now I'm going to put two 10 buff capacitors in, one in each place. Now between the two of them there should be a resistance between the two positives. The negative goes to deck, well the positives, it's about a K, which is about right actually. More sets, it's about a K. As that resistor goes open circuit, then either one of the caps is short circuit or something else has done it further down the line. But it's usually a K. So that one and that one both are going to have a 10K, a 10 watt capacitor to deck. So that's our next job. I'm not going to put them up on the top side of the panel. I'm going to put them here. Okay, so I'm going to put them here. Okay, so again, same again. I'll do that and we'll take it from there. Right, two new caps are under the chassis there, because of course new capacitors are a hell of a lot smaller, so that tree there. Heat sinks in place as well. That cap has been changed, and of course there's also now a line cord or a mains cord on as well. So let's see what happens without any valves in, and we'll see now what it does. So that goes on to there. So we switch it to AC volts. AC volts. We'll put it where you can see it. Can you see that? Okay. So that's the AC volts. So as soon as I plug it in like that, there should be voltage. That's on, right? And there should be some voltage on there, which there is. Okay, fine. So the AC is getting to the radio. Now at this point now, the next thing we need to do is look at whether a valve lights up in its place. If it does, then I know for a fact that this is an AC only set. So put it down like that and put the valve in like that. Again, at some point there we are, right? Put that in just for the sake of tidiness, and then of course in it goes again, and see if that valve lights up. And it does. That valve lights up. Okay, fine. If that one lights up, then there's no HT anywhere, so they can go anywhere, so that can go in there. Well, that one lights up. Well, that one lights up, and it is doing. Okay. Now all we're checking here is the heater chain, nothing else. So there's really nothing else it can be here, you know. That one lights up as well, and this one back here should also light up, and it does. So we know therefore that the valve chain is working, is correct, and the valves are in parallel, which means that I can put them in one at a time and see what happens. I'll change that capacitor on the grid of this valve as well, so we might get something here. We should do, let's put it that way, we should do. And so, with the rectifier in the circuit now, again, we apply mains, like that. By the way, some people insist on using a step-up unit or a variac. In some cases it's necessary, but something like this, really, I tend not to, because, well, life's too short, basically, like Chris said, and you know, the important thing is getting the thing working. So on the pencil, therefore, 278 volts there, into there. The rest of them should have nothing on them. But there's two pins here that have 270, and I'm not sure that that isn't something with the valve, a valve internal connection. So again, back to the internet we go, and we type in 6V6GT, and we'll see if it comes up twice. And no, it doesn't. We might have a problem here. So underneath we go, and we'll check those connections thoroughly and make sure. The anode is pin 3. The fact that the voltage there suggests that the transformer is okay. Pin 4 is G2. Pin 5 is G1. Pin 6 is no connection, and so on. So what I'll do, I can now put this valve in like that. You find out which is which. Difficult thing, by the way, well actually, it's hold on to pin 1 like that. So it's 1, 2, 3, 4, 5. Okay, fine. So we'll put those in again. Sometimes when there's no connection, but unfortunately there is a connection on the unit itself, so inside the unit. So I'll check that. Pin 6. Pin 6. Right, pin 6. The pin 6 is no connection. So maybe that pin is used as an anchor point. That does happen, by the way. Sometimes you get a pin used as an anchor point. But again, always check. Check, check, and check again. When you put the 6B6 in here, it's very quiet. Very quiet. A lot more quiet than it should be. Now that could be the valve. Indeed, it's possible. But in days gone by, you could get another one, put it in, and check. But now, really, they're expensive, so you can't do that anymore. So we check everything else first. And first thing we check is the speaker and the 8-volt transformer. The speaker, it should make a noise when you put current across it, and it doesn't appear to be doing that. It could be that, but it could be the fact that I don't know what value that speaker is, but we can check and see. But the other thing we can do is check the voltages on the valve itself. Now before we put the valve back in, well, I want to look at pins 3 and 4. This is because on a beam test rod or a Pennines rod, it takes current from 2 areas. One is the anode, and one is the cathode. The anode, by the way, goes to the main transformer, and that looks okay. Yeah? And that looks okay too, by the way. But I'm also going to check between the two, and this is because there's a 4.7k resistor between the two, and this goes high or short circuit. And when it does, which it hasn't done here, I don't think, hang on, climbing because there's current on it, but it's obviously not bang on 4.7, but it doesn't appear to be likely to cause complete silence or very quiet operation. So in with the valve, the right way around please, like that. Put the set on its front, like that. And I'll have a look around here at the various places where check up voltages. And also we check the voltages on the anode, the second grid, which is tied to mains, tied to HV positive as well, and the cathode. Now here, a few interesting things to note. First of all, with the valving circuit, when it's warmed up, the voltage should be less. Can you see that okay? Can you actually? I think you can, right, okay. Voltage should be less. So we'll look under here now and see what we can find. Nothing, okay, fine. Now, the two smoothing capacitors are linked by, are linked of course by a resistor which is 1K. So between the two of them, there should be a voltage there as well. Which doesn't seem to be readily available from the top of the machine, which is a bit of a pain, but these things do happen. But as you can hear, even when I touch the capacitor here, there is absolutely nothing. So it's either the speaker, the output transformer, the valve, which is possible, and I must admit very likely, or the cathode resistor. Now on sets of this kind, I'll just turn that round a bit so you can see, not the power a minute. Can you see that? I can anyway. On sets of this kind, the cathode resistor actually puts the voltage on the cathode of the amp up to 8 volts. And the reason why it does that is because the first grid, where the anode voltage is, has to be I'm doing something. 2, 4. Okay, that seems to be about right. Glasses on. Need those more and more, you know, it does worry me a bit. Anyway, so that's 148. This one is that's 0. That's 0. So the problem with the voltage is 1.9 there, okay. Obviously so the voltages are not quite right around here. So this is the first place we will look. So if you take out the grid resistor again and look on that pin, that big capacitor again, and look on that pin, we should be able to see something of use. But we can't. Okay, fine. Okay, well I think the best thing to do here is to take out the 6V6 just in case. It has got warm. It has got warm. Not got hot, but got warm. So now we'll have a look and see. By the way, I noticed actually that there's no hum either, which is equally interesting. So yeah, with the tape, by the way, there should be some serious voltages, not even more serious voltages knocking around here. So whether they are. That's okay. Again, very low, very low. Even about something there. Also, the capacitor here, capacitors here as well. Now, the capacitor on this circuit here, there is one across the output transformer, which does need to be removed. So I'll find that, rip it out, and we'll try again. What I've done here now is I've put this 6V6 back in and the next farther along, which is a 6 hang on, it is a 6Q, hang on, it's a 6G, hang on, can't read that, 6Q7G. Okay, now that means therefore that the top here will also generate a signal if I do that. So I'm going to do that. I'll put it on. I'll put it in and see what it does now. Ah. There we are. So that capacitor was obviously the problem. That capacitor, by the way, went across the primary of the output transformer. In the days when this was made, it had it as a tone corrected capacitor. They didn't, so I tended to whip them out and leave them out. But with that in mind now, I'm going to do something just to see what happens now. I'll put the other two valves back in, that's the IF valve there, and the frequency changer valve, which is this one here. There we go, put that back on there like that. Switch on and see what happens now. Give you a bit of help by putting that back on there.
Red light, green light, and they have to cross the red line on the other side of the huge room. So without further ado, green light. Red light. Stop.
Bit distorted, but there is
Squid Game
well, there is 5 Live
like
with the aerial
to 100,000. He's watched paint dry. He's trying to live underwater.
So we have therefore now nearly working radio. Yes, it's working, and Wasn't that valve. Was not that valve, so that saved a lot of money there. But it's not quite right. Now the problem there is probably due to more of these capacitors over under here going pear-shaped over the years. So I think the next thing we do is change certainly if you look here, there's that one. I'll turn it around. There we are. Right. If you look here, there's that one, and that one, yeah, which needs to be changed. So I'll get on with those three and we'll take it from there. But we now have a working radio. So it's had two smoothing caps which I've replaced. It's had the grid cap replaced, one cap taken out of circuit, which is fair enough, and of course this as well here. By the way, that is shot. What's an aerial attached to this set is this here. I'll put that on at the end when I put the thing back together. But for now, let's change those caps and see if it improves matters. Now with this set now, it's a pilot little Maestro. There's several of these on the market actually, and this is, as far as I can tell, circuit for this set, apart from the fact that this set is medium wave and long wave, not medium wave and short wave. There's a slight difference there, but that is neither here nor there for something like this. Basically I've changed C3 down here and so that's marked C3A, that C7 and C10. The other ones that were of this kind of capacitor. One up one actually, look inside. These paper capacitors, what they do over the years is that they absorb moisture from the atmosphere and they go low in value and leaky, and so that's the best place for them. Okay, I've put in these, by the way. You get these off eBay pretty cheap and private places, and they do the job perfectly well. They are actually 630 volt, which is well suitable, and of course 104J means 0.1 microfarads. Again, at some point I will go through column values for you in that noting. Also, what changed, of course, these capacitors, intermittent capacitors, I've changed. That one, C12, very important. I've changed that straight away. That one was faulty. I took it out of the circuit and the thing worked, but I'll leave it out because it doesn't really matter that much on a set like this. So no, it is a reasonably working set, as you see here. By the way, the difference, the reason why this is a set but with short wave and medium wave, that's for the foreign market. Over here in England, it's long wave.
Actually travelled 31 hours from the States and landed and found out the game was cancelled. It's just not good enough. And second, again and again and again, the light.
They're going into long wave. It's very noisy in here on long wave, but well, there's radio 4. Now I'll just try and put the set's on aerial back on it and see if it'll pick it up with a bit more purity, as it were. I can get the aerial out from here. It's where it should be on the dial, by the way. I checked it with the too noisy here, but I know that this way it should be on the dial because I've checked it with the generator. There it is. It's there. That needs a bit of spray, that. But it's there. That's about that is more or less where it should be on the dial. right there. So that's looking okay. So now, of course, it's simply a matter of
Of the rules have been broken over and over again. Why does that not matter to you?
Naveen, have you?
there you go. Somebody talking about the spirit of the rules of probably football, you know. So I'll talk about it Saturday night on that station. Boring as hell. But anyway, there you are. So I'll go on. I'll look at this socket down here and try and make long wave a little bit better. Well, there's an island actually on long wave there. The radio 4 is a bit long, but that is nicer, I think. So yeah, so it is working. The problem actually was the light fitting in here. It's putting at all sorts of crap on the long wave band, which it wasn't doing earlier on. So I don't know what to do about that just yet. But there you are. It's working on long wave as well. That's off somewhere on my meter. So I think we can say this one's done. So electronically. So now we'll go and sort out the bring it back together again and start to get all the cosmetics. Just one other thing I'll mention here. First of all, I changed the dial light to the front, so down the lights up. But most of these sets are supposed to have 2 IFTs. This has only 1, but it does have 2. That one is, I think, circuit is the first one, which is there, yeah, and the other one is under the chassis. It is in fact there. Both of them, but sometimes one is hidden away under the chassis. Anyway, Chris tells me he wants to tidy up the chassis and do the cosmetic work himself, which is fine. So what we'll do now, we'll put the thing back together and let him do that himself. So I've given the inside of the cabinet a bit of a scrape, not in that way, you know. So now it's a case of putting the set together again, and there we go. These sets, of course, they are a bit American in the design, like I said, but there are a few things here which you wouldn't find on the American AFI. There are a few differences. One, obviously, is the transformer. AFIs work on the resistor principle, which can be replaced by a capacitor if need be. And also, the AFIs work on 120 volts rather than this one works on 240. Again, there are ways to deal with that, such as, again, the capacitive dropper for the valve heaters and the extra resistor for the HT, or the Americans call the valve filament supply what we call LT. They call it filament supply, and the HT they call the battery supply, I think. So that's something to look out for. I'm using British terminology, but the Americans, of course, slightly different with that. Also, the American sets, the rectifier in these also tap off the rectifier heater supplies the bulb. This is not from British sets, so that's something else to look forward to as well. Also, although I'm not going to bother relining this one, IFs, of course, are not always where you think they will be. Always get a manual, always have a look into it. Most of them on FM, apart from a few, looking at U-Bus, it's 10.7 megahertz. On AM, which is what these are, most cases, but not all by any means, it's 450 and 470 kilohertz. Some of the sets elsewhere, it can be around 300, 250, or around 120. Check it. If you're not sure, most sites do it. I should tell you that there's information for nothing, so that's something else. So anyway, this now goes into here, and we put the set back together again. So we do it very carefully, because at this stage we don't want anything to fail, do we? It's our own hands, so you know we do it carefully, and we make sure that it goes in like that. Okay, right, so that's it now. Now, a set that's apart and a set that's together are two different sets. That might seem obvious, but believe me, it's true. Number of times, by the way, that I've had a set perfectly on the bench, put it into the cabinet, switch it on, nothing. It's nobody's business. So when you're putting a set back together again, always check it as you're doing it, just to be sure. Okay? It can come with simply a wire going somewhere it shouldn't, so it could be anything, but it does happen. Also, don't tighten up all the screws until it is actually in place, because that's another no-no, believe me. So with this one now, when I put the third screw in the bottom here, at some point, then I will then plug it in and check it again to make sure that it's still working. Yes, it does happen. It happens an awful lot. It's one of those things which, newbies in particular, check it every step of the way. And also, if you're doing capacitor changing, change one or two capacitors, check. Change one or two capacitors, and check. This is because a set will work okay with the old capacitors in, but when you change them, it only takes there to be one put in on the wrong terminal, and the thing won't work. And when that happens, you've got to go back and find it, and you might not be able to do that in that situation. So always together, check, together, check, together, check, and so on. Yes, I've thought of that one too, by the way. I did a tape recorder a while ago actually, which was like that. And the problem was down to a tape recorder head. And when I put the head back on, it bent the wiring out of place and shorted out the head. And so it worked perfectly with the thing apart, but put it together, switch on, and it didn't want to know. It does happen, believe me. Right, anyway, here it is on the bench, working away quite happily now. I'll put it up a bit so you can see, but it's working quite well.
He's really close to
That's
us,
Five Live.
They're very structured, but the move.
Talk Sport. Virgin, or Absolute as it's called now. That's my station I use for lining stations on there. And a few more as well knocking about across the dial, but there's not a lot on AM these days, so yeah. Now, the aerial it came with is what it's got now, which is this lot here. It does actually affect it when I'm moving it about.
Just a few moments ago, very lucky that they went to goal down. Almighty goal mouth played. Brighton 0, Chelsea 0. Just having a look at our monitor at the definitely Alonso got the ball.
So there we are. This is now a set that's working away happily again. What I've done with it, therefore, dial light obviously. Here's a circuit, just for reference. I didn't need it, but I changed capacitors that needed to change, of course, including this one here. And now it is. It's a set that will work for another 50, 60 years or so. So until next time, this is Steve. It's Steve Longs to Vintage Radio Workshop saying goodbye and take care. And I'll see you soon. Bye bye.
In his bright yellow shirt, Thiago Silva, who crossed to Antonio Rudiger, who in turn finds Alonso, chased by